Okay, welcome back. This is the famous roller coaster problem, and the idea here is that you have to start the roller coaster at 4 times the height of the loop. So actually, way up here, right? Way up here, 4 times the height of the loop in order for something to make it all the way around. And so the question here is, what's the work that is done by friction if this is the case? Well, finding the work done by friction is hard, but finding the work done by everything else and the net change in kinetic energy, that's easy. So that's how we're going to do this problem. So the first thing we're going to want to do is we're going to want to find what needs to be happening here at B. And in order to just barely make it around, this means that the normal force at the top of the loop goes to 0. So at this point, you have only the gravitational force downward. And the sum of the forces is then just mg, and that's mv squared over r. That's going around in a circle. So the m's cancel, and we get that v is the square root of gr. So that's the speed you need to have in order to be going around. Notice that this means we did this problem with forces. There are some things that you have to invoke forces, but the rest of the problem we're going to use energy, because we're going to say that k plus u at the top is equal to, if we start from rest, 1/2 mv squared is just 0, plus, well, let's see, if you have to start at 4 times the height of the loop, that's m times g times 4 times 2 times r. The height of the loop is its diameter, so that's the energy at the top. K plus u at, so maybe I shouldn't call it top, maybe I should call it start. At the start. And at the loop top, we have 1/2 mv squared, where v squared is going to be g times r, plus mg, and now you're just 2r above the ground. So what we find is that there's a difference between these two things, right? So one of these is going to be 8 mgr, and the other one of these is going to be 2 plus 1/2 mgr. So 2.5 mgr, which means you have less energy when you get to B than you had when you started at A. So that means that the work that is done by the non-conservative force is the change in the kinetic plus the potential energy, where potential energy is the change in the potential energy. The take-home message here, the change in the potential energy is negative the work done by conservative forces. Okay, so, but basically the non-conservative forces means whatever seems to be missing, that mechanical energy has been converted into thermal energy, and the difference between 8 and 2.5 is 5.5 mgr, and that's the answer.